The open road calls to us. For generations, that journey has been fueled by gasoline. But what if the future of driving is not a roar, but a hum? Across the globe, a silent revolution is underway. Electric cars are no longer a futuristic fantasy. From sleek sports cars to family-friendly SUVs, electric vehicles are transforming the automotive industry. This shift is driven by technological advancement, environmental awareness, and a desire for a sustainable future. The internal combustion engine has served us well for over a century, but its reign is coming to an end. Electric cars offer a cleaner, more efficient alternative. They promise a future where transportation no longer chokes our cities with smog. Buckle up as we embark on a journey to explore the fascinating world of electric cars. Imagine a world without the rumble of engines, a world where cars glide silently through the streets, emitting nothing but a gentle hum. This is the promise of the electric car revolution. It's a revolution driven by necessity, innovation, and a growing awareness of our planet's fragility. Electric cars produce zero tailpipe emissions, reducing air pollution and improving urban air quality. Governments are implementing policies to incentivize electric car adoption, and automakers are investing heavily in electric vehicle technology. We are witnessing a paradigm shift in the automotive industry, a shift towards a future where electric vehicles are not the exception but the norm. The allure of electric cars extends beyond their environmental benefits. They represent a departure from our dependence on fossil fuels, a finite and increasingly volatile resource. Electric cars offer the potential for greater energy independence. Moreover, electric cars can be powered by renewable sources like solar and wind power. The electric vehicle industry is creating new jobs in manufacturing, research and development, and infrastructure. The pace of innovation is rapid, and these challenges are being addressed with each new generation of electric cars. The rise of electric cars is not just about replacing one type of car with another. It's about reimagining the very concept of personal transportation. Electric cars are smart cars. They are connected to the internet, capable of over-the-air updates, and increasingly autonomous. The integration of electric cars with smart grids has the potential to revolutionize energy management. The electric car revolution is still in its early stages, but its impact is already being felt. The idea of an electric car is not new. It predates the gasoline-powered car by several decades. In fact, the first practical electric car was built in the 1880s, long before Henry Ford's Model T rolled off the assembly line. These early electric vehicles, while rudimentary by today's standards, captured the imagination and hinted at a future of clean, efficient transportation. Despite their early promise, electric cars faced an uphill battle. Gasoline-powered cars, while initially less reliable and more difficult to operate, benefited from the discovery of vast oil reserves, which made gasoline readily available and inexpensive. Electric cars, unable to compete on price or range, gradually faded into obscurity. Despite being relegated to the sidelines, electric cars never truly disappeared. Throughout the 20th century, inventors and engineers continued to tinker with electric vehicle technology, driven by a desire for cleaner, more efficient transportation. The 1970s oil crisis sparked renewed interest in electric vehicles. Several automakers, including General Motors and Volkswagen, began experimenting with electric vehicle prototypes. These prototypes showcased the potential of electric cars, but they still suffered from limited range and slow charging times. Battery technology remained the biggest hurdle. The oil crisis had demonstrated the vulnerability of relying on a single, finite energy source, and it had spurred innovation in electric vehicle technology, albeit on a limited scale. Electric cars, once again, retreated to the fringes of the automotive industry. The late 20th and early 21st centuries witnessed a confluence of factors that would reignite the electric car revolution. Concerns about climate change and air pollution reached a fever pitch. Governments began implementing stricter emission standards and offering incentives for fuel-efficient vehicles. At the same time, technological advancements, particularly in battery technology, were making electric cars more viable. This period saw the emergence of companies like Tesla, which challenged the status quo of the automotive industry. Tesla, founded in 2003, focused solely on electric vehicles, aiming to create high-performance electric cars that could compete with and even surpass their gasoline-powered counterparts. Established automakers, initially dismissive of Tesla and the electric car movement, began to take notice. The giants were awakening from their slumber, and the race to electrify the road had begun. At the heart of the electric car revolution lies the battery. It's the single most important component determining the range, performance, and cost of an electric vehicle. Lithium-ion batteries, first commercialized in the 1990s, have revolutionized portable electronics, powering everything from smartphones to laptops. The cost of lithium-ion batteries has plummeted over the past decade, driven by economies of scale and advancements in manufacturing processes. This cost reduction has been a game changer for electric vehicles, making them increasingly affordable for the average consumer. Researchers are constantly working on improving battery technology, exploring new materials and chemistries to increase energy density, extend battery life, and reduce charging times. The development of a robust battery recycling infrastructure is crucial for the long-term sustainability of electric vehicles. The electric car revolution is gaining momentum, but several challenges remain before electric vehicles become the dominant mode of transportation. Range anxiety, the fear of running out of battery charge before reaching a charging station, is a common concern among potential electric car buyers. However, the range of electric cars has been steadily increasing, with many models now offering over 200 miles on a single charge. The availability of charging infrastructure is crucial for the mass adoption of electric vehicles. Governments and private companies are investing heavily in building out a network of charging stations, including fast charging stations that can replenish a significant portion of battery charge in minutes. Government incentives, such as tax credits and rebates, are making electric vehicles more affordable for consumers, further driving adoption. The electric car's resurgence is inextricably linked to advancements in battery technology. Lithium-ion batteries, with their high energy density and declining costs, have been instrumental in propelling electric cars into the mainstream. But the quest for better batteries continues, driven by the relentless pursuit of longer range, faster charging, and enhanced safety. Solid-state batteries, a tantalizing prospect on the horizon, promise to leapfrog the capabilities of lithium-ion batteries. Beyond solid-state batteries, researchers are exploring a diverse range of battery chemistries, from lithium-sulfur to lithium-air batteries, each with its own set of advantages and challenges. This relentless innovation in battery technology is not just about improving the performance of electric cars, it's about unlocking new possibilities in energy storage, with implications for everything from portable electronics to grid-scale energy storage. The transition from internal combustion engines to electric motors represents a fundamental shift in how we power our vehicles. Electric motors, with their instant torque, silent operation, and remarkable efficiency, offer a driving experience that is both exhilarating and serene. Unlike gasoline engines, which rely on a complex system of pistons, crankshafts, and gears to convert fuel into motion, electric motors operate on a simpler principle, using magnetic fields to generate rotational force. This simplicity translates into several advantages, including fewer moving parts, reduced maintenance, and inherent reliability. The most striking difference between driving an electric car and a gasoline-powered car is the instant torque. Electric motors deliver maximum torque the moment you press the accelerator, resulting in breathtaking acceleration and effortless passing power. This shift towards electric motors is not just about improving the driving experience, it's about reducing our reliance on fossil fuels and paving the way for a cleaner, more sustainable transportation future. Electric cars are not just about using energy efficiently, they're also about recapturing energy that would otherwise be lost. Regenerative braking, a technology inherent to electric vehicles, transforms the act of slowing down into an opportunity to replenish the battery, extending range and enhancing efficiency. In a traditional gasoline-powered car, braking generates heat as kinetic energy is dissipated through friction. Electric cars, however, utilize this energy, turning the electric motor into a generator during braking. As the car decelerates, the electric motor, now acting as a generator, converts the kinetic energy of the spinning wheels back into electrical energy. Regenerative braking is just one example of how electric cars are designed not just to consume energy but also to conserve and reuse it, maximizing efficiency and minimizing environmental impact. In the world of automotive engineering, weight is the enemy of efficiency. Every kilogram saved translates into improved acceleration, increased range, and reduced energy consumption. Electric car designers, acutely aware of this relationship, are constantly pushing the boundaries of lightweighting, employing innovative materials and design techniques to shed every possible gram. Traditional steel, while strong and durable, adds significant weight to a vehicle. Electric car manufacturers are increasingly turning to lightweight materials such as aluminum, magnesium, and carbon fiber to construct key structural components, reducing overall weight without compromising safety or performance. Aluminum, known for its high strength-to-weight ratio, is widely used in body panels, chassis components, and even battery casings. Magnesium, even lighter than aluminum, finds its way into structural components, instrument panels, and even seat frames. Carbon fiber, the darling of high-performance cars, offers exceptional strength and rigidity at a fraction of the weight of steel. While expensive, carbon fiber is increasingly being used in electric cars, particularly in high-end models, to reduce weight and enhance performance. This relentless pursuit of lightweighting extends beyond material selection. Designers are optimizing vehicle architecture, streamlining shapes, and even using lighter-weight interior components to trim every possible gram, maximizing efficiency and extending range. As an object moves through the air, it encounters resistance, a force known as aerodynamic drag. This drag force, if not carefully managed, can significantly impact a vehicle's efficiency, particularly at higher speeds. Electric car designers, acutely aware of this, are obsessed with aerodynamics, sculpting shapes that cheat the wind and enhance efficiency. Gone are the days of boxy, utilitarian electric vehicles. Modern electric cars boast sleek aerodynamic profiles optimized through countless hours of wind tunnel testing and computational fluid dynamics simulations. Every curve, every crease, and every air intake is meticulously designed to minimize drag and maximize range. The goal is to create a vehicle that slices through the air with minimal resistance, reducing energy consumption and extending range. This attention to detail extends beyond the overall shape of the car. Designers are paying close attention to seemingly minor details such as door handles, mirrors, and even the underbody of the car, smoothing out airflow and minimizing turbulence. This focus on aerodynamics is not just about achieving impressive drag coefficients. It's about maximizing efficiency, extending range, and squeezing every last mile out of a single charge. Electric cars are more than just vehicles, they are rolling computers, seamlessly integrated into the digital world. This connectivity, enabled by an array of sensors, processors, and wireless communication technologies, is transforming the driving experience, enhancing safety, convenience, and entertainment. Imagine a car that can anticipate your needs, warn you of potential hazards, and even learn your driving habits to optimize energy consumption. This is the promise of the connected car, where data flows seamlessly between the vehicle, the driver, and the outside world. Navigation systems, once limited to static maps and turn-by-turn directions, now provide real-time traffic updates, suggesting alternative routes to avoid congestion and minimize travel time. Over-the-air software updates, delivered wirelessly, keep the car's systems up to date, ensuring optimal performance and security. Remote vehicle monitoring, accessible through smartphone apps, allows owners to check battery status, preheat or cool the cabin, and even locate their car in a crowded parking lot. This seamless integration of technology enhances convenience, safety, and the overall driving experience. The connected car is not just about convenience, it's about paving the way for a future of autonomous driving, where cars can communicate with each other and with infrastructure, creating a safer and more efficient transportation ecosystem. The electric car revolution is linked to autonomous driving. Electric vehicles provide an ideal platform for self-driving technologies. Imagine cars navigating roads and transporting passengers autonomously. This vision is becoming a reality, driven by AI and sensor technology. Electric cars offer control and responsiveness essential for autonomy. Sensors provide a 360-degree view, feeding data to onboard computers. Developing autonomous driving technology requires data, algorithms, and testing. The benefits include improved safety, reduced congestion, and enhanced mobility. Electric cars are catalysts for a shift in transportation, enhancing our lives. For over a century, the internal combustion engine has dominated our roads, leaving behind a trail of harmful emissions. These emissions, a toxic cocktail of pollutants, have choked our cities, compromised our health, and altered our planet's delicate climate balance. Electric cars offer a radical departure from this polluting paradigm. With zero tailpipe emissions, they represent a breath of fresh air, literally and figuratively, promising cleaner air, healthier communities, and a more sustainable future. The impact of air pollution on human health is undeniable. Respiratory illnesses, cardiovascular problems, and even certain types of cancer have been linked to prolonged exposure to vehicle emissions. Children and the elderly are particularly vulnerable. They're developing or compromised respiratory systems, struggling to cope with the onslaught of pollutants. Electric cars, by eliminating tailpipe emissions, offer a direct and immediate solution to this public health crisis. As electric car adoption grows, we can expect to see a gradual but significant improvement in air quality, particularly in densely populated urban areas. This transition to cleaner transportation is not just about improving public health, it's about addressing a global environmental crisis that threatens the very future of our planet. The transportation sector is a major contributor to greenhouse gas emissions, accounting for a significant portion of global carbon dioxide emissions. These emissions, primarily from burning fossil fuels, trap heat in the atmosphere, contributing to climate change and its devastating consequences. Electric cars offer a pathway to decarbonizing transportation, shifting away from fossil fuel dependence and towards a more sustainable future. By replacing gasoline-powered cars with electric vehicles, we can significantly reduce carbon emissions, mitigating the impacts of climate change. The extent to which electric cars can reduce emissions depends on several factors, including the source of electricity used to charge them. In regions where electricity generation relies heavily on coal or other fossil fuels, the emissions reduction benefits of electric cars are diminished. However, as the electricity grid transitions towards renewable energy sources, such as solar, wind, and hydropower, the carbon footprint of electric cars shrinks dramatically. In some cases, electric cars charged with renewable energy can achieve near zero emissions over their entire life cycle. This transition to a decarbonized transportation system is not just about switching to electric cars, it's about transforming the way we generate and consume energy, embracing renewable sources, and building a more resilient and sustainable energy infrastructure. While the absence of tailpipe emissions is a major environmental advantage of electric cars, it's crucial to consider the broader environmental impacts throughout their entire life cycle. from raw material extraction to manufacturing, use, and eventual disposal. The production of electric cars, particularly the batteries, requires significant amounts of energy and raw materials, some of which can have environmental implications if not sourced and processed responsibly. Mining for lithium, cobalt, and other critical battery materials can lead to habitat destruction, water pollution, and social conflicts in some regions. However, advancements in battery technology, recycling processes, and responsible sourcing practices are mitigating these environmental concerns. Manufacturers are increasingly using recycled materials in battery production, reducing the demand for virgin materials. Furthermore, the environmental impact of electric car manufacturing must be weighed against the cumulative emissions from gasoline production, transportation, and combustion over the lifetime of a gasoline-powered car. When considering the full life cycle, electric cars generally have a lower carbon footprint than their gasoline-powered counterparts. This holistic perspective is essential for making informed decisions about the environmental sustainability of electric vehicles, recognizing both the benefits and the challenges throughout their entire life cycle. The battery is the heart of an electric car, and its life cycle is crucial for sustainability. Addressing battery production and disposal challenges is essential. Mining for materials like lithium and cobalt has significant impacts. Open-pit mining can lead to deforestation and habitat destruction. Recycling batteries recovers valuable materials and reduces waste. The environmental benefits of electric cars are amplified when they are charged with electricity generated from renewable sources, such as solar, wind, and hydropower. The transition to a decarbonized electricity grid is essential for maximizing the emissions reduction potential of electric vehicles. In regions where electricity generation relies heavily on fossil fuels, the carbon footprint of electric cars is higher, although still generally lower than that of gasoline-powered cars. However, as the grid incorporates more renewable energy sources, the emissions associated with charging electric cars decrease significantly. Governments, utilities, and businesses are investing heavily in expanding renewable energy infrastructure, driven by concerns about climate change, energy security, and the economic benefits of clean energy. As renewable energy capacity grows, the electricity grid will become cleaner, further reducing the environmental impact of electric cars. Consumers can also play a role in this transition by choosing renewable energy plans from their electricity providers, installing solar panels on their homes, and supporting policies that promote renewable energy development. The synergy between electric mobility and renewable energy is a powerful force for creating a more sustainable transportation future. Cities choked by traffic and pollution can benefit from electric mobility. Electric cars offer zero emissions and quieter operation, creating healthier urban environments. Imagine clean air, quiet streets, and safe roads for all. This is the promise of electric mobility. Electric cars can significantly improve urban air quality. Reduced air pollution means fewer health issues. Quieter cities are more pleasant to live in. Less noise pollution reduces stress and sleep disturbances. Electric cars create a more tranquil urban environment. Shared mobility with electric cars can reduce traffic congestion. Fewer cars on the road free up urban space. The transition to electric mobility is an imperative driven by the urgent need to address the climate crisis. Climate change is real, human-caused, and its impacts are already being felt. Rising global temperatures, more frequent heat waves, melting glaciers, rising sea levels, and extreme weather events are consequences of fossil fuels. The transportation sector must transform to mitigate these impacts. Electric cars, powered by renewable energy, offer a scalable solution. The urgency of the climate crisis demands bold action. The time for incremental change is over. We need a paradigm shift in how we power our lives. The future depends on embracing sustainable technologies. The electric car revolution is not just about cleaner transportation. It's about sparking economic growth and transforming industries. As the world shifts gears towards electric mobility, new industries are emerging, traditional sectors are adapting, and job creation is accelerating. The most immediate impact is felt in the automotive industry itself. Manufacturing plants are being retooled, assembly lines are being reconfigured, and workforces are being trained for the electric era. This transformation is creating a surge in demand for skilled labor, from electrical engineers and software developers to technicians and assembly line workers. But the ripple effects extend far beyond the factory floor. The rise of electric cars is fueling a parallel industry dedicated to charging infrastructure. Companies are springing up to design, manufacture, and install charging stations in homes, workplaces, and public spaces, creating a vast network of charging points to support the growing electric fleet. This in turn is driving innovation in areas like battery technology, power electronics, and grid management. Research and development are buzzing with activity as companies compete to create more efficient batteries, faster charging systems, and smarter grids that can handle the increasing demand for electricity. The electric car revolution is not just changing how we drive, it's changing how we live, work, and power our world. Imagine a world where refueling your car is as simple as plugging in your phone. This is the vision of a future powered by electric vehicles with a robust charging infrastructure. Fast charging stations are popping up along highways, allowing quick battery replenishment. Shopping malls, restaurants, and apartments are installing charging points as standard amenities. This proliferation of charging options alleviates range anxiety and supports mass adoption. Smart charging technologies optimize times and minimize grid strain. The future of charging is about creating a seamless, intelligent, and sustainable energy ecosystem. The electric car revolution is driven by a shift in consumer attitudes. Buyers prioritize sustainability, efficiency, and technology. Electric cars offer zero emissions and performance benefits. They are now synonymous with innovation and a cleaner future. The electric car revolution is not just transforming the automotive industry, it's reshaping the geopolitical landscape, shifting alliances and sparking a global race for technological dominance. At the heart of this transformation lies the promise of energy independence. For decades, many countries have been heavily reliant on oil imports, their economies vulnerable to price volatility and geopolitical instability. Electric vehicles offer a path towards energy security, reducing dependence on foreign oil and fostering domestic energy production. This shift is particularly significant for countries with ambitious climate goals. By transitioning to electric mobility and investing in renewable energy sources, nations can reduce their carbon footprint, meet their international commitments, and position themselves as leaders in the global fight against climate change. The race to dominate the electric vehicle market is intensifying, with countries vying for a share of this rapidly growing industry. Governments are implementing policies to incentivize electric car adoption, supporting domestic manufacturers and investing heavily in research and development. The electric car revolution is not just about cleaner transportation. It's about national security, economic competitiveness, and global leadership in a world transitioning to a low-carbon future. The electric car revolution is well underway, but the road ahead is not without its bumps and detours. Challenges remain, opportunities abound, and the future of mobility is ripe with possibilities. One of the most pressing challenges is the need for continued investment in battery technology. While battery costs have declined dramatically, further advancements in energy density, charging speed, and lifespan are crucial for extending range, reducing costs, and making electric vehicles even more appealing to consumers. Another challenge lies in expanding charging infrastructure, particularly in rural areas and along highway corridors. Governments and private businesses must collaborate to create a seamless and convenient charging network that alleviates range anxiety and supports long-distance travel. The transition to electric mobility also presents opportunities to rethink transportation systems and urban planning. Cities can leverage the rise of electric vehicles to promote shared mobility options, reduce traffic congestion, and create more livable urban environments. The electric car revolution is not just about replacing one type of car with another, it's about transforming our relationship with energy, our cities, and our planet. It's about embracing a future where transportation is cleaner, more efficient, and more sustainable. The road ahead may be long and winding, but the destination is a future worth striving for. From the cobblestone streets of the 19th century to the bustling highways of today, the journey of the electric car has been marked by fits and starts, moments of brilliance overshadowed by technological limitations and a societal reluctance to relinquish the familiar roar of the combustion engine. But the electric spark, once a flicker of innovation, has ignited a revolution, transforming not just the automotive industry but the very fabric of our energy landscape and our vision of a sustainable future. The electric car is not merely a mode of transportation, it's a symbol of our collective decision to choose a path less traveled, diverging from unsustainable reliance on fossil fuels. This shift is driven by climate concerns, energy independence, and economic opportunities in green tech. Electric vehicles offer zero emissions and align with renewable energy goals. They reshape industries and foster innovation. As we peer through the windshield into the future of transportation, the horizon shimmers with the promise of a cleaner, more electrifying world. Electric cars, once a niche curiosity, are poised to become the dominant mode of transportation, their silent hum replacing the roar of the combustion engine as the soundtrack to our daily lives. The road ahead is not without its challenges. Continued investment in battery technology is crucial for extending range, reducing costs, and making electric vehicles accessible to all. Expanding charging infrastructure, particularly in rural areas and along highway corridors, is essential for alleviating range anxiety and ensuring a seamless transition to electric mobility. But the opportunities outweigh the challenges. The rise of electric vehicles presents a chance to rethink urban planning, promote shared mobility options, and create cities designed for people, not just cars. It's an opportunity to break free from our dependence on fossil fuels, embrace a future powered by renewable energy, and mitigate the worst impacts of climate change. The electric car revolution is a testament to the power of human innovation and our collective capacity for change. It's a journey towards a brighter, cleaner, and more sustainable future, and it's a journey we must take together. So buckle up, embrace the electric spark, and let's steer towards a horizon illuminated by the promise of a more electrifying tomorrow.